Trigonometric integrals. What do you do when you have integrals that have a combination of sine, cosine, or secant, tangent, or just sine to some power, cosine to some power, and likewise with secant raised to whatever power and tangent raised to a power? You want to recall some preliminary identities from trigonometry. Obviously, sine squared x plus cosine squared x equal to 1. Sine square x is equal to 1 minus cosine 2x over 2, and then cosine square x equal to 1 plus cosine 2x divided by 2. Here are some guidelines for integrating the combinations of sine raised to a power times cosine raised to a power. And what you want to notice here from these instructions is that when you have the combination for integral of sine raised to a power, cosine raised to a power, if the sine has an odd power, you're going to take one, 2k plus 1, take one of those signs and write it as sine to the first power. And then the remaining signs, which would be to an even power, you can use the identity 1 minus cosine square x is equal to that sine square. And then manipulate the problem in that fashion where you will end up using a u-du substitution. And probably about once or twice, just depends. The same idea for combination of sine cosine where cosine has an odd power. Take one of the signs and then the remaining signs would be even, and then you take those even terms for the sine squared to whatever kth power, and you write the sine square as 1 minus, you write the cosine square, excuse me, as the 1 minus sine square x. Okay, I don't know what that 1/2 is sitting over there for. It's odd. Okay. Anyway, let's look at some problems. See if we can make some sense out of this. Let's just use blue for today. So notice here, there's no need to even go through the process of what we just got through talking about, because the cosine to the 5th x and the sine x, since there's only one sine x, we can use directly a u-du substitution and get what we want. Let me show you. That's too thick. Let u equal to one of those cosine x's. So that implies that du is equal to negative sine x dx. So that is negative du is this sine x dx. So cosine, which is going to be u to the 5th power, and then this expression here would be represented by negative du. So that be the case, we have the integral of u to the 5th negative du represents this integral. And so this is negative u to the 6 over 6 plus c. This is negative, the u was cosine to the 6x all over 6 plus c. So that was pretty neat, where we didn't have to go about using the process that's in this section. Now look at the difference between number 5 and number 1, where this is cosine to the 5th times sine x. The difference is that one of these terms is even. One of them is even, and it doesn't matter about the nature of this guy, but it is odd. Now if both powers were even, then you're going to use that half angle formula. If only one of them is even, and then there's no other trig function associated, you still use the half function. And I'll show you one of those in just a moment. So we're going to write this guy This is odd, so we're going to say this is the integral of sine. We're going to take 1, so this is sine square x times sine x times cosine square x dx. We're going to write the sine square x as 1 minus cosine square x to connect with that cosine square. So this is the integral of 1 minus cosine square x times sine x cosine square x dx. And we simplify this, so we just distribute. So this is sine x cosine square x, and this is minus sine x times cosine to the 4th x dx. Now you can write these as two integrals. This is the integral, and it needs to be in parentheses. Write this as sine x cosine squared x dx minus the integral of sine x cosine to the 4th x dx. Now this looks now like number 1. There's only one term, sine, to the first power. If it was cosine to the first times sine to whatever power, we still use the u du substitution. So here, you always, in terms of u du for these trig combinations, let u equal to, look at the trig function that's raised to a power. You take one of those and let that equal to u. So let u equal to cosine x. And du is negative sine x dx. The du will pick up that term by itself, right, in the differential, the dx. So this is negative du is equal to sine x dx. The same thing happens over here, so we keep the same u du terminology. So we write it. Now the first integral is going to be the u squared, because this is cosine squared, so this is u squared, and then du is negative sine dx. We don't have negative sine dx, so we say negative du represents the sine x dx. So negative du represents that one. So then minus the integral here, this is u to the 4th, and the negative du represents this sine x dx. So negative times that negative is a positive du. So we integrate. Remember that negative is sitting there. This is negative u to the 3rd all over 3 plus u to the 5th all over 5 plus c. Go back and put in the u as cosine, and so this gives us negative cosine to the 3rd x all over 3 plus sine to the 5th x all over 5 plus c. Let's look at this number 9. It's only one term here, and it's even, so we use, and I can write that, we're going to use the fact that cosine square x is equal to 1 plus cosine 2x all over 2. So this becomes the integral of 1 plus, so it's the double. If it's x, it's 2x. So if this is 3x, it's going to be cosine 6x all over 2 dx. So you can break this up into two integrals. This is 1/2 dx plus 1/2 times the integral of cosine 6x dx. And a straight integration on this guy, for this cosine 6x, you have to use u du substitution because of that 6x there. So over here, let u equal to 6x and du is equal to 6 dx. Sorry for spitting. Think about my old grandmother. And so 1 over 6 du represents the dx. So the dx here is going to be represented by the 1/6 du, and this is going to be cosine of u. So we have, again, this is the integral of 1/2 dx plus 1 over 2, and the cosine, this is the integral of cosine u, and then the du divided by 6 represents the dx. So we just say 1/6 there. So now we integrate and do not hesitate. This is 1/2 x plus this is 1 over 12. The integral of cosine is sine of u, but the u, remember, it's the 6x. So this is sine 6x plus c. Now, with this guy, it's a sine squared x. Anytime we have sine squared by itself or cosine squared by itself, we use that double angle. So you can write this as the integral of x, and this is times 1 minus cosine 2x all over 2 dx. Then you can write this as the integral of x over 2 dx minus 1/2 times the integral, just distributing this x over 2 to the first term. The 1 dx was just x over 2 dx, and then x over 2 times the negative cosine 2x. So this is x cosine x dx. This is direct integration, and over here we use integration by parts, and the shortcut would be the tabular method. So we use parenthetically the tabular method. All right, the tabular method. That's an R there. Hard for me to write on this screen. It's hard for me to write on any screen. Cannot cuss, but we can spit. Getting better. So we use that tabular method. It's x, take the derivative of x, this that x there. It's 1, take the derivative of 1, we get 0, alternate the signs. Then we take cosine 2x, we integrate here. Now here this is a u du as well. Let u equal to 2x, and so du that implies that 1/2 du will be the dx in that integration. So what this comes out to be, the integral of cosine, you remember, is sine but then it's going to be times the result of the dx, which is 1/2. So it's going to be a 1/2 here times sine 2x. We integrate again. It's going to be always a factor of a 1/2, so it's going to be 1/4. The integral of this sine is negative, so it's basically negative. The integral of the sine 2x is negative 1/2 cosine 2x. So 1/2 times 1/2 is 1/4. This is cosine 2x. And this is for the second integral, right? So we integrate this term here. This is the integration of x over 2 dx minus the 1/2 times the integral of x cosine 2x dx. So this is the integral of x is x squared divided by 2, and so times this 2 downstairs, so this is 1/4 x squared minus 1/2 times, this is integration by parts. We got that by the tabular method, so we plug that in. This is x over 2 times sine 2x. Minus a minus is positive 1/4 cosine 2x. Close that up, plus some constant there. So we write all of this as 1/4 x squared minus x over 2 sine 2x minus 1/8 cosine 2x plus c. I think that's all we got for today. Thank you.